Hello there and welcome to the Sleepy Scientist channel. Tonight we'll be looking upward into the vast and beautiful expanse of the night sky. A place filled with light, with wonder, and endless mysteries. Above us are the usual sights, the moon, the constellations, and the planets we're all familiar with. But there's so much more than meets the eye. Some of the stars we see have already faded, their light only just arriving. A simple cloud may be an entire galaxy, millions of light-years away, and the bright flash of a meteor may be something no larger than a grain of sand. The night sky is both ordinary and spectacular, something we see every day yet never ceases to amaze. If you enjoy these quiet explorations, I invite you to like and subscribe or share a simple thought down in the comments. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is rest, settle in, and allow the calm of the night sky to carry you. Let's begin. Every star you see with the naked eye belongs to our own galaxy. When you step outside on a clear night and let your eyes adjust to the darkness, the stars scattered across the heavens can feel infinite. Yet, every single one of those points of light that you can see without a telescope is a neighbor, part of our own Milky Way galaxy. Astronomers estimate that the unaided human eye, under the best conditions, can make out roughly 6,000 stars across the entire sky. Compare that to the Milky Way's true population, hundreds of billions of stars, and you realize how small a sample we're actually seeing. The galaxies beyond, like Andromeda or the faint smudges of distant spirals, are simply too far away for their stars to be seen individually. Instead, they blur into ghostly glows. What you see with your eyes alone is just the tiniest sliver of the vast community of suns we live among. Some stars in the night sky are already dead, their light still traveling toward us. Looking at the stars is like looking into the past. Light moves incredibly fast, but space is so vast that even starlight takes years, centuries, or millennia to arrive. Some of the twinkling points you see on a calm evening may have left their home long before humans first built cities. A bright star 100 light-years away is sending you an image of how it looked a century ago. In some cases, the star itself may no longer exist. He could have swollen into a red giant, collapsed, or even exploded as a supernova. But its light keeps racing outward, still crossing the gulf of space, still reaching us as though nothing has changed. It means the night sky is not a present snapshot, but a moving archive, a living record of what was. Each shimmer above us is both here and gone, alive and vanished all at once. Polaris has not always been the guiding North Star. For travelers in the Northern Hemisphere, Polaris has long been a faithful companion. Sitting almost exactly above Earth's North Pole, it marks true north in the sky. But Earth itself slowly wobbles on its axis in a cycle called precession. Over thousands of years, this gentle motion shifts the position of the stars relative to our poles. Polaris has not always been our North Star, and it will not remain so forever. In the time of the ancient Egyptians, for example, the star Thuban in the constellation Draco held that title. In about 12,000 years, the brilliant Vega will take its turn. This slow celestial dance means that humanity's guiding star changes with the ages. Polaris feels eternal when we look at it tonight, steady and bright. Yet even it is just one marker in a long and shifting cycle written across the heavens. Ancient travelers navigated oceans and deserts by patterns in the night sky. Long before compasses and satellites, the sky was humanity's first map. Sailors crossing the vast Pacific memorized the rise and fall of constellations, using them as guides over featureless waves. Nomadic peoples in deserts did the same, orienting themselves by the position of stars. Polaris, steady above the northern horizon, was especially valuable for finding direction. In the southern hemisphere, navigators used the Southern Cross. Entire systems of knowledge grew around these observations. Polynesian wayfinders, for example, carried the positions of hundreds of stars in memory, passing them down through generations. These maps were more than practical. They were cultural treasures woven into stories and songs so they could never be forgotten. When you look up at the night sky, you're seeing the same compass points that once guided caravans, armies, and explorers, carrying them across oceans and continents long before any mechanical device existed. The Milky Way appears as a hazy band because we are looking through its disk. On a truly dark night, far from city lights, a misty river of light stretches across the sky. This is the Milky Way, and its glow comes from the combined light of billions of distant stars. The reason it forms a band is that we are inside the galaxy looking along its flat disc-like structure. Imagine standing inside a vast spinning wheel and gazing through its rim. That's what we see from Earth. The concentration of stars, gas, and dust in the disk blurs together into a luminous haze. In ancient times, cultures around the world gave it names: a celestial river, a road of spirits, the backbone of the night. Today, we know it as the plane of our galaxy. And every glowing wisp in that band is another sun, another solar system, another possible world. The Milky Way is both home and horizon. Our galaxy contains hundreds of billions of unseen suns. The stars you see overhead are only the tiniest fraction of what actually fills our galaxy. Astronomers estimate that the Milky Way contains somewhere between 200 and 400 billion stars. Most of them are too faint or too distant to be seen without telescopes. Many are red dwarfs, small and dim compared to our sun, but incredibly numerous. Others are hidden behind clouds of gas and dust, their light only revealed through infrared observations. There may also be countless wandering worlds, planets not bound to any star, drifting unseen through the dark. When you look up at a night sky filled with a few thousand stars, it's humbling to realize that what you see is only a pinprick of the Milky Way's true population. Our galaxy is so full of suns that even in a lifetime, no eye could ever count them all. Shooting stars are not stars at all, but grains of cosmic dust burning in the night sky. The streak of a shooting star feels magical, sudden, bright, and gone in an instant. But despite the name, these flashes aren't stars. They're usually fragments no bigger than a pebble, often smaller than a grain of sand. As they plunge into Earth's atmosphere at tens of thousands of miles an hour, the air in front of them compresses and heats up, causing them to glow brilliantly before disintegrating. Most never reach the ground. What we see is their final blaze, a farewell spark in the sky. Some arrive from comets, the trails leaving behind streams of dust that Perth crosses each year. Others are simply random debris wandering the solar system. They may be tiny, but their brilliance comes from speed and energy, not size. In every streak, the universe leaves us a fleeting reminder that space is never still. From the darkest places on Earth, thousands more stars appear in the night sky. Most of us live under skies dimmed by artificial light. Street lamps, cities, and glowing highways all wash out the stars. But in the rare places untouched by this glow, remote deserts, mountaintops, isolated islands, the view changes entirely. Instead of a few dozen bright points, the heavens become densely crowded, alive with thousands upon thousands of stars. The Milky Way swells into a broad, glittering arc, bright enough to cast shadows. In these skies, you can see faint smudges that are actually distant galaxies, glowing clusters of stars, and sometimes even the delicate color of nebula. Astronomers call such places dark sky sanctuaries, and they are increasingly rare. To stand beneath one is to see what every human before modern lighting once saw. A universe alive with stars, humbling in its immensity and breathtaking in its clarity. Some places never glimpse the Milky Way because of light pollution. For many people around the world, the Milky Way is no longer a part of daily life. In heavily populated regions, Artificial light has erased it from view. Entire generations grow up without ever seeing the river of stars that was once central to human culture. Light pollution doesn't just dim the stars, it drowns them completely, leaving only the brightest planets and a few scattered points. Cities that glow all night send light upward, scattering in the atmosphere and creating a permanent haze. As a result, in some places, the Milky Way is effectively gone, yet the stars are still there, waiting behind the veil. Astronomers and conservationists are working to preserve dark skies, not just for science, but for our sense of wonder. To see the Milky Way with your own eyes is to reconnect with a view that belongs to all of humanity. Constellations slowly change shape over thousands of years. Constellations feel timeless, their patterns passed down through generations as if frozen in the sky. But in truth, the stars that make up Orion, Ursa Major, or Cassiopeia are not fixed points. Each star is moving through the galaxy with its own velocity, its own trajectory around the galactic center. Because they are so far away, their motions are imperceptible to us within a single lifetime. Yet over tens of thousands of years, the familiar outlines we know begin to warp and dissolve. Orion's belt will eventually lose its straight line. The Big Dipper will no longer look like a dipper at all. Astronomers can project forward in time to see how the sky will appear in the distant future, and the constellations are nearly unrecognizable. The night sky is not a permanent picture, but a slow shifting dance, one that reveals how dynamic our galaxy truly is. The southern hemisphere reveals constellations northern eyes never see. For anyone raised under northern skies, traveling south of the equator can feel like stepping into a new world after sunset. Familiar constellations like the Big Dipper vanish completely, sinking below the horizon. In their place, new shapes emerge. The Southern Cross, bright and compact, long used by navigators. Nearby, the two Magellanic Clouds, small galaxies orbiting our own, appear as ghostly smudges visible to the naked eye. Entire patterns of stars form constellations unfamiliar to northern stargazers. The emu in the sky, recognized by indigenous Australians, or the majestic Centaurus striding across the heavens. For those in the southern hemisphere, these constellations are as natural and recognizable as Orion is to the north. Together, they remind us that the sky is shared. But perspective changes everything. Half of Earth sees a view the other half never does, and the universe above is always larger than what we know. The Andromeda Galaxy is faintly visible in the night sky without a telescope. Most galaxies lie far beyond the reach of human eyesight, but one is close enough to reveal itself unaided. Andromeda. Under dark skies, it appears as a dim, misty blur, more like a cloud than a structure of stars. Yet that hazy smudge is staggering in scale. Andromeda is a spiral galaxy like our own, containing perhaps 1 trillion stars, stretching more than 200,000 light-years across. Its light has traveled over 2 million years to reach Earth. Ancient observers saw it too, long before telescopes existed, and recorded it as a faint patch among the stars. To realize that you can step outside, look up, and actually see another galaxy with your eyes alone is one of astronomy's most humbling experiences. That faint blur is not just a single object. It's an entire island universe with suns, planets, and mysteries of its own. The light from Andromeda began its journey more than 2 million years ago. When you glimpse the faint glow of the Andromeda Galaxy, you are looking into the deep past. Its light has traveled for more than 2 million years across intergalactic space. That means the glow reaching your eyes tonight left Andromeda long before humans existed. When that light began its journey, Earth was home to early ancestors who had not yet developed the tools or language we take for granted. Entire species have risen and fallen in the time it has taken for that faint gleam to cross the void. And while we see Andromeda as it was, the galaxy itself has moved, evolved, and continued to form new stars. In another 4 billion years, Andromeda and the Milky Way will collide and merge into a single vast galaxy. For now, the light from its ancient stars serves as a living time capsule, carrying history across unimaginable distance. The night sky once contained stars that no longer exist today. It is easy to think of the stars as permanent, eternal lights above us. Yet stars are born, live, and die, often in violent ways. Because starlight takes time to reach Earth, some of the stars recorded in ancient times have since perished. Astronomers studying old star charts occasionally discover descriptions of bright objects that no longer shine in today's sky. These may have been massive stars that exhausted their fuel and exploded as supernovae, leaving only faint remnants behind. Others may have collapsed into neutron stars or black holes, invisible without specialized instruments. The sky is constantly renewing itself, with new stars being born even as old ones fade away. What we see above us is not a fixed tapestry, but a changing story, a record of both what is and what once was. Every glittering point is temporary, even if its life far outlasts ours. A star's color reveals its temperature, from cool red to blazing blue. Not all stars shine the same. Some glow with a soft orange-red, others with a pale blue-white brilliance. This difference is more than cosmetic. It reveals their temperatures. Red stars, often called red dwarfs or red giants depending on their size, are cooler, radiating at a few thousand degrees. Blue stars, by contrast, blaze at tens of thousands of degrees, their surfaces searing hot and their lifespans short. Our own sun, with its steady yellow-white light, sits in between, a medium-temperature star. To astronomers, these colors are like fingerprints. By splitting starlight into its spectrum, they can measure temperature, composition, and even motion. To the human eye, the colors of stars are subtle, often masked by the atmosphere. But with practice, you can spot them. Each color tells a story about a star's nature, its energy, and its place in the grand life cycle of the cosmos. Stars appear to twinkle in the night sky because of Earth's atmosphere. The twinkle of a star can feel enchanting, like nature's own sparkle. But what you're really seeing is turbulence in Earth's atmosphere. A starlight travels through the layers of air above us. It bends and shifts slightly with changing densities and temperatures. The effect makes the light appear to flicker or jump, even though the star itself is shining steadily. Planets, by contrast, usually appear more stable because they are closer and present a larger disk of light, less affected by the shifting air. Astronomers call this effect atmospheric scintillation, and it's the reason telescopes on Earth can never achieve perfect clarity. To overcome it, observatories are built on mountaintops where the air is thinner and steadier, or even launched into orbit to bypass the atmosphere entirely. What looks like a magical shimmer is really a reminder of the thin, restless blanket of air we live beneath. In space, those same stars shine with steady clarity. Astronauts aboard the International Space Station, or spacecraft beyond Earth's atmosphere, see stars very differently from us. Without the constant interference of air currents, starlight arrives in perfect beams, steady and unwavering. The difference is striking. Instead of twinkling points, stars shine with sharp precision, each one a fixed jewel against the blackness. This clarity is one reason telescopes like Hubble produce images of breathtaking detail freed from Earth's atmosphere. They can capture the universe as it truly looks. The steady glow in space also reveals the subtler colors of stars more vividly than what we usually see from the ground. While twinkling can feel romantic or nostalgic, the view from orbit shows the sky in its raw form, stable, radiant, and clear. It's a reminder that our atmosphere both protects and distorts, sheltering us while gently disguising the true face of the cosmos. Some stars grow hot enough to fuse helium and carbon deep inside. The energy of a star comes from nuclear fusion, the process of pressing smaller atoms into larger ones. For most of its life, a star fuses hydrogen into helium, but massive stars don't stop there. As their cores grow hotter and denser, they begin fusing helium into carbon, oxygen, and even heavier elements. This cycle builds the building blocks of life itself. Every atom of carbon in your body, every molecule of oxygen you breathe was created inside a star that once blazed and burned. Eventually, when such stars reach their limits, they collapse and explode, scattering these elements into space to seed new stars and planets. The cosmos is a kind of recycling system, with each generation of stars creating the raw materials for the next. When we look up at a brilliant blue giant or a fading red supergiant, we are seeing furnaces that forge the future. Sirius blazes as the brightest star in the night sky. Sirius, known as the dog star, dominates the night with its brilliance. Found in the constellation Canis Major, it shines nearly twice as bright as the next brightest star, Canopus. Its name comes from the Greek word for glowing, and it has lived up to that reputation across cultures and centuries. Part of its brightness comes from proximity. Sirius lies only about 9 light-years away, making it one of our nearest stellar neighbors. But it is also intrinsically luminous, shining more than 20 times brighter than the sun. Ancient Egyptians watched for its rising, linking it to the flooding of the Nile. Today, it is still one of the most reliable markers in the winter sky. Easy to spot, even from cities, Sirius is not alone either. It has a faint white dwarf companion, the dense core of a long dead star orbiting it every 50 years. Sirius has inspired myths across nearly every culture. From ancient Mesopotamia to the Pacific Islands, Sirius has been more than just a bright point of light. It has been a symbol, an omen, and a guide. The Egyptians associated its yearly rising with the life-giving floods of the Nile, weaving it into their calendar. The Greeks linked it with heat and madness, giving us the phrase dog days of summer. In Polynesian navigation traditions, it was an essential star for long voyages. For indigenous peoples of North America, it appeared in legends and seasonal markers. Across the world, cultures recognized its brilliance and gave it significance, tying it to cycles of agriculture, migration, and storytelling. That Sirius can be so many things to so many people speaks to its power. It is just a star, a ball of burning hydrogen and helium. Yet its place in human imagination has made it one of the sky's most enduring symbols. The Pleiades cluster sparkles like a tiny swarm of fireflies in the night sky. The Pleiades, sometimes called the Seven Sisters, is one of the most beloved sights overhead. This small cluster of stars lies in Taurus and is visible even in areas with some light pollution. Through the naked eye, most people see 6 or 7 stars, though in reality, the cluster contains hundreds. With binoculars, the view transforms into a glittering swarm, each star a youthful blue sun burning brightly. Ancient cultures around the world recognized the Pleiades, often weaving them into myths of family or pursuit. The Japanese name for the cluster is Subaru, now immortalized in the car company's logo. The Pleiades are relatively close by, only about 400 light-years away, and still wrapped in faint dust clouds that reflect their light. They are a reminder that not all beauty in the night sky is distant or faint. Some wonders are close enough to feel intimate. The Orion Nebula glows faintly within Orion's sword. If you trace the constellation Orion, beneath his famous belt lies a short line of stars known as the Sword. In its center is a fuzzy patch of light visible to the naked eye on dark nights. This is the Orion Nebula, one of the brightest and closest stellar nurseries in the galaxy. Through binoculars or a small telescope, it resolves into swirls of glowing gas lit by newborn stars, Astronomers estimate that thousands of stars are forming there, shaping the clouds with their energy. To ancient stargazers, it was simply a mysterious blur. But today we know it as a place where the story of stars begins. The Orion Nebula is only about 300 light-years away, close enough that it has become one of the most studied regions in the sky. Every glance at it is a look at creation in progress. Some nebulae shine because their gases are energized by nearby stars. Nebulae are the great canvases of the cosmos, clouds of gas and dust that stretch for light years. Some glow brightly because they are energized by powerful radiation from nearby stars. Ultraviolet light streams out from these massive suns, striking the atoms in the nebula and causing them to emit colorful light of their own. These are called emission nebulae, and they paint the sky with reds, greens, and blues, depending on the elements within them. The Orion Nebula is one famous example, glowing with pinkish light from hydrogen. Without the stars that energize them, these clouds would be dark and invisible, blending into the void. Instead, they shine as luminous beacons signaling regions where stars are born. What looks delicate and soft to us is, in fact, a cauldron of activity, shaped by energy and gravity into some of the most beautiful sights in astronomy. Others glow only by reflecting starlight, like cosmic mirrors. Not all nebulae create their own light. Some simply reflect the brilliance of nearby stars. These are called reflection nebula, and they shine in a softer, gentler way. Dust grains within them scatter starlight, often giving them a distinctive blue hue, much like Earth's sky appears blue because of scattered sunlight. One famous example is the nebulosity surrounding the Pleiades cluster, where bright blue stars illuminate faint clouds of dust. These nebulae are like cosmic mirrors catching and redirecting light across the void. They often appear near young star clusters where plenty of hot, bright stars are available to shine on them. Though less dramatic than glowing emission nebulae, reflection nebulae are delicate reminders that the universe is full of subtlety as well as grandeur. They are the whisper to the other neighbor shout, faint but exquisite in their quiet shimmer. Many stars are not single, but pairs orbiting each other. When you look up at the sky, it's easy to imagine each star as a solitary sun, but in reality, many are not alone. Binary systems, pairs of stars orbiting a common center of mass, are incredibly common. Some are nearly equal in size, dancing around each other in graceful balance. Others are mismatched with a massive star tugging a smaller companion in wide loops. To the eye, many binaries appear as a single point of light, their closeness masking their dual nature. With telescopes, astronomers can separate them or detect their influence through gravitational pulls. These systems are not rare curiosities, but may actually be the norm. Our sun, in its solitude, could be the exception rather than the rule. Binary stars remind us that even in the vast loneliness of space, companionship is common and the universe is full of unlikely partnerships. Binary systems are more common than solitary suns like ours. It might seem natural to assume that most stars resemble the sun, solitary, with a family of planets in orbit. But surveys suggest the opposite. Binary and multiple star systems may outnumber single stars. In some cases, stars form together from the same cloud, locked into gravitational bonds that last for billions of years. In others, stars capture each other later through close encounters. Binary systems can be peaceful, or they can be tumultuous. A massive star can strip material from its smaller partner, creating spectacular disks of gas, or one can collapse into a white dwarf, neutron star, or black hole, reshaping the relationship entirely. For planetary systems, life under two suns would be profoundly different. Imagine a sky with double sunsets, or a world where two dawns rise each morning. Solitary stars like ours are special, but perhaps not the most common story in the galaxy. There are even triple and quadruple star systems bound together. If two stars orbiting each other seems complex, nature goes even further. Some systems host 3 or even 4 stars bound together in intricate gravitational relationships. In a triple system, 2 stars may orbit closely while a third circles farther out, like a cosmic dance with nested steps. In quadruple systems, the arrangements can become even more elaborate, with pairs orbiting pairs. To us, they may appear as a single point of light, but telescopes reveal the truth, a miniature galaxy in its own right. For any planets within these systems, the skies would be extraordinary. Sunrises and sunsets could involve multiple suns casting overlapping shadows and floods of shifting light. These systems are reminders that the cosmos is inventive, crafting arrangements far beyond the familiar. While our single sun feels normal to us elsewhere, entire solar systems live under the glow of several suns at once. Cepheid variable stars pulse rhythmically like cosmic lighthouses in the night sky. Some stars do not shine with steady brightness. Cepheid variables expand and contract in a regular rhythm, causing their light to brighten and fade in cycles that can last days or weeks. To the naked eye, they appear to flicker on cosmic timescales, but to astronomers, they are invaluable tools. The period of their pulsation is directly related to their intrinsic brightness. By measuring how quickly they pulse and comparing it to how bright they appear, astronomers can calculate their distance. This discovery, made in the early 20th century, unlocked the ability to measure the scale of the universe. Cepheids became mile markers, showing us the vast distances to nearby galaxies. What began as the curiosity of a star that seemed to breathe in and out became one of the most important tools in cosmology. Each pulsing cepheid is both a marvel and a measuring stick for the cosmos. These pulsations once revealed the true scale of the universe. For centuries, the size of the universe was a mystery. Were the stars nearby pinpricks or unimaginably distant? Cepheid variable stars provided the answer. In the 1920s, astronomer Edwin Hubble studied cepheids in the Andromeda Galaxy. By measuring their pulsation periods, he determined their intrinsic brightness, and from that, their distance. The result was staggering. Andromeda was far beyond the limits of the Milky Way. It was another galaxy altogether. The discovery expanded the universe overnight, transforming it from a single island of stars into a cosmos filled with countless galaxies. Cepheidus were the key, simple, rhythmic beacons that bridged the gulf between us and the wider universe. Today, even with advanced telescopes and satellites, they remain essential tools for measuring cosmic distances. Each pulse is a heartbeat of the cosmos, steady and reliable, reminding us how the simplest patterns can unlock the greatest truths. Some stars balloon into red supergiants, hundreds of times larger than the Sun. Not all stars remain small and steady like our Sun. Some, when they near the end of their lives, swell into titanic red supergiants. These stars expand to such immense proportions that if one replaced the Sun, its surface could stretch beyond the orbit of Mars. Despite their size, their outer layers are thin, glowing with a deep red hue as the star struggles to sustain itself. Within, their cores fuse heavier elements in a frantic effort to maintain balance against gravity. These giants live fast and die young, their immense energy burning through fuel at astonishing rates. They are rare compared to smaller stars, but unforgettable in scale and brightness. Looking up at one is to glimpse a dying star in its final chapter, swollen and unstable, destined for collapse. Red supergiants remind us that even the grandest stars cannot escape time. Betelgeuse in Orion is nearing the end of its life. High on a winter night, the constellation Orion dominates the sky. At his shoulder burns Betelgeuse, a ruby-red star that has fascinated stargazers for centuries. Betelgeuse is a red supergiant swollen to hundreds of times the size of our Sun. Astronomers know it is nearing the end of its life, having exhausted the hydrogen that once fueled it. Inside, it now fuses heavier elements, building toward an inevitable collapse. Betelgeuse's brightness varies dramatically, sometimes dimming so noticeably that it sparks speculation across the world. In 2019, a great fading LED made to wonder if it was about to explode. Although it returned to its usual glow, the event reminded us of its fragile state. Betelgeuse is a star in its twilight, and its fate is sealed. Whether it endures for another 100,000 years or only a fraction of that, it will eventually die in spectacular fashion. Betelgeuse may one day explode as a supernova, visible in the night sky, even in daylight. When Betelgeuse finally reaches the end, it will not fade quietly. It will explode as a supernova, a detonation so powerful it will outshine all other stars in the sky. For weeks or even months, the light from its death could be visible even during the day, brighter than the full moon. Such an event has happened before in history, recorded by ancient astronomers when nearby stars collapsed. Betelgeuse lies about 600 light-years away, close enough for us to witness its brilliance, but far enough to pose no danger to Earth. The explosion will leave behind a dense remnant, perhaps a neutron star, while its outer layers scatter across space, enriching the cosmos with elements like oxygen and iron. When it happens, humans everywhere will look upward, seeing the same brilliant beacon in the sky. A reminder that stars too live and die in extraordinary ways. Supernova can briefly outshine entire galaxies. The death of a massive star is among the most violent events in the universe. In a supernova, the collapsing core rebounds with such ferocity that the entire star is torn apart in a single instant. For a brief period, the explosion can release more energy than all the other stars in a galaxy combined. From Earth, such events may appear as sudden bright stars where none existed before. Some fade within weeks, others linger for months. Beyond their spectacle, supernovae serve as cosmic engines, scattering the elements forged in stellar hearts into surrounding space. Without them, the building blocks of planets and life would not exist. The brilliance of a supernova is fleeting, but its legacy endures forever. To imagine an entire galaxy overshadowed by the death of a single star is to glimpse both the power and the impermanence written into the fabric of the cosmos. The Crowd Nebula is the remnant of an explosion recorded in the night sky by ancient astronomers. In the year 154, observers in China and across the world recorded the sudden appearance of a dazzling new star. It shone brightly for weeks, visible even in daylight before fading from view. Today, we know that event was a supernova, the death of a massive star. The remnant still lingers in the sky known as the Crab Nebula. Through telescopes, it appears as a tangled web of glowing filaments, the expanding shell of gas and dust cast off by the explosion. At its center lies a pulsar, the collapsed spinning core of the original star, still sending out pulses of radiation like a cosmic lighthouse. The Crab Nebula is a time capsule, a living bridge between ancient records and modern astronomy. When we see it, we are seeing both the memory of a star's death and the continuing life of its remnant. Pulsars spin with such precision they rival atomic clocks. Pulsars are among the strangest objects in the cosmos. They are the collapsed cores of massive stars left behind after a supernova, composed almost entirely of neutrons. They are unimaginably dense. A teaspoon of pulsar matter would weigh as much as a mountain. Many pulsars rotate at astonishing speeds, sending beams of radiation sweeping across the universe like the beams of a lighthouse. From Earth, these appear as regular pulses of light or radio waves, each one arriving with such reliability that astronomers can use them as cosmic clocks. Some pulsars spin dozens of times per second, while the fastest known rotate hundreds of times each second. Their stability rivals that of the best atomic clocks on Earth. allowing astronomers to use them for measuring cosmic distances and testing the laws of physics. These tiny collapsed remnants remind us that time itself can be written in starlight. Magnetars wield magnetic fields trillions of times stronger than Earth's. Among the many exotic remnants of dead stars, magnetars stand apart. Like pulsars, they are neutron stars, but they possess magnetic fields so intense they defy comprehension. A magnetar's field is trillions of times stronger than Earth's, capable of distorting atomic structures themselves. These fields can twist and snap violently, producing bursts of high-energy radiation that ripple across space. Astronomers detect them as sudden flares, brief but powerful. Though small, only about 20 km across, magnetars contain the mass of multiple suns. Their strength makes them dangerous even at great distances. A magnetar close to Earth could wreak havoc on our planet's magnetic field. Fortunately, none exist nearby. Instead, they remain distant curiosities, extreme laboratories, where the rules of physics are pushed to their limits. Magnetars show us that the universe is not just vast, but capable of producing forces so extreme they border on the unimaginable. Black holes hide in the night sky, revealed only by their effects. A black hole is not an object we can see directly. Its gravity is so strong that not even light can escape, rendering it invisible against the backdrop of space. Yet their presence can be detected by what they do to their surroundings. Matter spiraling into a black hole heats up, glowing brightly in X-rays before vanishing. Stars caught in their pull may orbit unseen companions, betraying the black hole's mass. Even space itself curves inward around them, warping the paths of light. To the naked eye, black holes are invisible. But through telescopes and careful observation, astronomers have uncovered many scattered throughout the galaxy. Some are the remnants of massive stars, while others lurk at the hearts of galaxies. They are the unseen anchors of cosmic drama, reminding us that the most powerful forces in the universe often hide in silence and shadow. Some consume nearby stars and flare brightly as they feed. When a black hole orbits close to a companion star, it can draw matter from its neighbor. Gas from the star spirals inward, forming an accretion disk, a whirling ring heated to millions of degrees. This process produces powerful X-ray emissions, making the earnest, invisible black hole one of the brightest objects in the sky at those wavelengths. To an observer, it looks like a flickering beacon, sometimes growing brighter, sometimes fading as the flow of matter changes. In extreme cases, black holes emit jets of material traveling near the speed of light, blasting across space for thousands of light years. Though the idea of a star being consumed sounds catastrophic, it is part of the cosmic cycle redistributing matter and energy. These dramatic systems reveal that black holes are not simply voids of emptiness, but active players in shaping the dynamics of galaxies. The heart of our galaxy conceals a supermassive black hole. At the very center of the Milky Way lies an invisible giant, Sagittarius A*, a supermassive black hole with a mass millions of times greater than the Sun. Though it cannot be seen directly, its presence is revealed by the orbits of stars whipping around it at incredible speeds. In 2019, astronomers captured its shadow for the first time using a network of radio telescopes spanning the globe. The image showed a glowing ring of light, matter heated to extremes as it spirals inward, surrounding a dark center where light itself cannot escape. Supermassive black holes like this one are thought to lurk at the cause of most galaxies, shaping their evolution through gravity and energy. That our own galaxy is anchored by such a force is both humbling and awe-inspiring. It is the silent heart of the Milky Way, unseen yet profoundly influential. Beyond our sight, the night sky holds countless galaxies. The stars above may feel abundant, but what we see is only the beginning. Beyond the Milky Way, countless galaxies populate the universe, Each contains billions, sometimes trillions of stars. With telescopes, faint smudges of light resolve into spirals, clusters, and ellipses, island universes scattered across the cosmos. The Hubble Space Telescope once stared at a seemingly empty patch of sky for days, revealing thousands of hidden galaxies in a space no larger than a grain of sand held at arm's length. This discovery showed that wherever you look, the universe is overflowing with galaxies. To the naked eye, only a few like Andromeda or the Melanic Clouds can be seen, but with the right tools, the blackness between stars transforms into an ocean of light. The night sky is not just a canopy of stars. It is the edge of a vast universe of galaxies. Through telescopes, galaxies appear in spirals, ellipses, and chaotic forms. Galaxies are not all alike. Some form graceful spirals with sweeping arms of stars curving outward from a bright core. Others are smooth and featureless ellipses, vast balls of ancient stars glowing faintly. Still others are irregular, their shapes distorted by collisions or bursts of star formation. Each type tells a story about its history. Spirals are active, full of young stars and gas. Ellipticals are older, quieter, often the result of merges. Irregulars are the misfits, still settling into shape. Through telescopes, the diversity of galaxies is astonishing. Some shine brightly, others appear as faint smudges, barely visible. Yet every one is a universe of its own, containing stars, planets, and mysteries beyond counting. To see them is to realize how endlessly inventive the cosmos is, shaping order and chaos alike into luminous forms that drift through the darkness of space. Some galaxies collide and merge in slow-motion dances. Though the distances between stars within a galaxy are immense, galaxies themselves are not so isolated. They are bound by gravity into clusters and groups, and their paths often intersect. When galaxies collide, it is not an explosive crash, but a slow-motion dance lasting hundreds of millions of years. Their stars mostly pass by one another, but their gas and dust clouds collide, triggering bursts of new star formation. Gravity stretches their shapes into spirals, tails, and arcs. Over time, the galaxies merge, becoming one larger system. Our own Milky Way is destined for such a fate, eventually merging with the Andromeda Galaxy. Far in the future, the two will become a single massive elliptical galaxy. For now, we watch others in the distance, their cosmic ballets frozen in time. Each collision a reminder that nothing in the universe is static, not even the galaxies themselves. The Melanic Clouds are two satellite galaxies visible in southern night skies. From the southern hemisphere, two faint cloud-like patches of light linger near the Milky Way. These are the large and small Melanic Clouds, dwarf galaxies orbiting our own. To the naked eye, they appear as subtle smudges, but through telescopes they reveal themselves as bustling systems filled with stars, clusters, and nebula. They are irregular in shape, distorted by their gravitational dance with the Milky Way. Within them lie stellar nurseries, like the Tarantula Nebula, one of the most active star-forming regions known. For observers in the north, the Melanic Clouds are invisible, forever hidden below the horizon. For those in the south, they are familiar companions woven into cultural traditions for centuries. These galaxies are reminders that the Milky Way is not alone, but part of a larger family of galaxies orbiting, merging, and shaping one another across cosmic time. Star clusters are like glittering families bound by gravity. Not all stars live in isolation. Many are born together in groups called star clusters bound by gravity. These clusters can range from small gatherings of a few hundred stars to massive groups containing thousands. Open clusters like the Pleiades are loose and youthful, their stars still close to their birthplace in interstellar clouds. Globular clusters, by contrast, are dense spherical gatherings of ancient stars tightly packed into dazzling spheres. To the eye, star clusters appear as sparkling knots, brighter than the stars around them. Through telescopes, they explode into fields of brilliance, each point of light a sun with its own story. Clusters are laboratories for astronomers, offering insights into stellar evolution and galactic history. To stand beneath a dark sky and glimpse one is to see a family of stars still holding together, bound by forces that have lasted for billions of years. Globular clusters can hold hundreds of thousands of suns. Globular clusters are among the most spectacular sights in astronomy. These spherical gatherings can contain hundreds of thousands, sometimes even millions of stars, packed into a region only a few dozen light-years across. In their centers, the density of stars is so great that they appear to blur together like a swarm of fireflies. Most globular clusters orbit the outer regions of galaxies, including our Milky Way, which has more than 100 of them. They are ancient, often more than 10 billion years old, containing some of the oldest stars in existence. To the naked eye, they may look like faint fuzzy patches, but telescopes reveal them as dazzling globes of light, globular clusters of fossils of the early universe, survivors from the time when galaxies were first forming. Their beauty lies not only in their glittering appearance, but in their endurance across cosmic history. Some of these clusters are nearly as old as the universe itself. Globular clusters are time capsules, preserving the earliest stars ever formed. Many are nearly as old as the universe itself, dating back more than 12 billion years. These ancient stars contain very few heavy elements, reflecting a time before supernovae had enriched the cosmos with the ingredients for planets and life. To study them is to look back into a nearly primordial universe when stars were first igniting in the dark. The fact that these clusters still exist today, orbiting the edges of galaxies, shows their resilience. They have survived countless galactic mergers, collisions, and gravitational disturbances, yet remain intact. When you gaze at one through a telescope, you are not just seeing stars. You are witnessing relics from the dawn of time, glowing beacons that have endured almost as long as the universe itself. They are among the oldest living witnesses of creation. Meteor showers return every year as Earth crosses comet trails in the night sky. Several times a year, Earth passes through streams of debris left behind by comets. As we move through these trails, countless tiny particles enter our atmosphere and burn up, creating meteor showers. Unlike random shooting stars, meteor showers produce multiple streaks within a single night, often radiating from a particular point in the sky. The Perseids, Geminids, and Leonids are some of the most famous, each linked to a parent comet or asteroid. These showers are predictable, recurring on the same dates year after year as Earth revisits the same paths. For stargazers, they are one of the most rewarding events to witness, filling the sky with fleeting streaks of light. Though the meteors are often no larger than sand grains, their fiery trails remind us that Earth is constantly moving through a living solar system, intersecting with the remnants of ancient wanderers. The Perseid meteor shower in August is among the most famous. Every August, the Perseid meteor shower graces the skies, producing some of the most reliable displays of shooting stars. Originating from the debris trail of Comet Swift-Tuttle, the Perseids are active for several weeks, but peak around mid-August. During this time, observers under dark skies may see dozens of meteors per hour, sometimes more during bursts. The Perseids are known for their bright, fast streaks, many leaving glowing trails that linger for moments after. They appear to radiate from the constellation Perseus, which gives them their name. For centuries, people have watched the Perseids, weaving them into folklore and marking them as a highlight of summer nights. Today, they remain a favorite for stargazers around the world, combining predictability with beauty. Each meteor is a tiny fragment of a comet, burning brightly as it falls, a yearly reminder of the connection between Earth and the wider cosmos. Ancient records describe brilliant showers streaking across the night sky. Meteor showers have not gone unnoticed by history. Ancient Chinese, Korean, and European texts describe sudden bursts of falling stars, sometimes numbering in the hundreds in a single night. These records often carried symbolic weight, interpreted as omens or portents. One famous Leonid shower in the 1830s produced thousands of meteors per hour, filling the sky with blazing streaks and sparking awe and fear alike. Witnesses thought the world might be ending. For astronomers, these historical accounts are more than curiosities. They help track the orbits of comets and the evolution of meteor streams. By comparing past records with modern observations, scientists can understand how debris trails spread and shift over centuries. What was once seen as mysterious fire in the sky is now recognized as a predictable cosmic event. Yet the wonder remains. Even today, when meteors fill the heavens, they inspire the same sense of awe. The Geminids are unusual, born from an asteroid rather than a comet. Most meteor showers are gifts from comets, fragile, icy wanderers that leave behind long trails of dust. But the Geminid, one of the brightest showers of the year, come from something stranger, an asteroid. Their parent body is rocky, compact, and behaves more like a burnt-out comet than a true asteroid. As it approaches the sun, Phaethon sheds dusty debris that Earth later crosses each December. When those grains slam into our atmosphere, they flare brilliantly as Geminid meteors. Unlike many other showers, the Geminids are famous for their intensity and their variety of colors, flashing white, yellow, and even green. At their peak, hundreds of meteors can streak across the heavens in a single night. That they come from an object neither fully comet nor asteroid makes them unique. A cosmic in-between, a reminder that not everything fits neatly into categories. Fireballs can blaze bright enough to cast shadows at night. Most shooting stars are faint streaks, gone before you can even make a wish. But every so often, one arrives with more brilliance than the rest. These meteors are called fireballs, and their light can rival or even surpass Venus, the brightest planet in the sky. A true fireball can momentarily cast shadows, illuminating the landscape like a brief silent explosion in the heavens. They're usually caused by larger fragments of rock or metal, sometimes as big as a fist or even larger, hitting the atmosphere at tremendous speeds. As they burn, they often leave glowing trails that linger for seconds. Some fragment and flare multiple times as though breaking apart in midair. Fireballs have startled people for millennia, inspiring awe and fear in equal measure. To see one is to witness a reminder of the energy locked inside even the smallest fragments drifting through space. Bolides explode with thunderous sound as they break apart. A bolide is a fireball taken to the extreme. It doesn't just blaze across the heavens, it detonates. These brilliant meteors explode in the atmosphere with enough energy to produce a flash that can rival the sun and a sound like rolling thunder. Sometimes they break windows or rattle buildings, as with the Chelyabinsk meteor in Russia in 2013. Bolides occur when larger meteoroids, perhaps meters across, strike Earth's atmosphere at hypersonic speeds. The immense pressure of the air causes them to fragment violently, releasing their stored energy in a tremendous burst of light and sound. Ancient records tell of skies filled with fire and booming noises, descriptions that almost certainly came from bolides. Though rare, they remind us that Earth is constantly passing through a shooting gallery of debris, and while most burn harmlessly, some arrive spectacularly, shaking the ground and echoing across the night. Earth is constantly brushed by tiny meteors every night. Even on nights with no meteor shower, Earth is quietly sweeping through streams of space dust. Tiny grains, often no larger than sand, strike our atmosphere continuously. Each one burns up in an instant, too faint for most eyes to notice. Astronomers estimate that more than 100 tons of meteoritic material fall into our atmosphere every single day. That means countless shooting stars are streaking above us at all times, though only a few are bright enough to catch our attention. Larger particles occasionally flare brightly, but most vanish unseen. These cosmic specks are the remnants of comets, asteroids, and collisions in the solar system, endlessly drifting until Earth happens to cross their path. To look up at the stars is to know that the sky is never still. Tiny pieces of the universe are always arriving, burning silently in the darkness. Some meteors leave glowing trails that linger in the night sky like smoke. While most shooting stars vanish in the blink of an eye, some leave behind luminous streaks that hang in the air long after the meteor itself has burned away. These trails are called trains. They form when a fast-moving meteor ionizes the gases in Earth's upper atmosphere, leaving behind a glowing path of charged particles. Depending on conditions, trains can shimmer for minutes, twisting and curling as high-altitude winds reshape them. Sometimes they resemble wisps of smoke, but unlike smoke, they shine faintly with their own ghostly light. Astronomers have studied these trails to better understand both meteors and the winds at the edge of space. For skywatchers, they're among the most magical sights of a meteor shower, like a signature written across the sky by something passing from one world into another, fading slowly as though reluctant to leave. The moon is our closest and brightest companion in the night sky. For as long as humans have looked upward, the moon has been our most faithful companion. It is far closer than any star, only about 238,000 parsecs away. And yet, it feels infinite in its moods and forms. It shines not with its own light, but with the reflected glow of the sun, waxing and waning in a cycle that shapes our sense of time. No other object dominates the heavens so completely. The moon has guided storytellers, inspired poets, and served as a natural clock for early civilizations. Its gravity pulls at our oceans, creating the tides that shape life along the shores. Unlike the wandering planets or fleeting comets, the moon is always there, rising and setting with quiet regularity. To step outside and see it is to share a view seen by every human who ever lived. Its phases served as humanity's first calendar. Long before written words or carved stone, humans tracked the sky. The most obvious cycle to follow was the moon's. Its waxing crescent, bright fullness, and fading crescent again form a repeating pattern of about 29-12 days. Early peoples used this cycle to mark the passing of time, planting and harvesting by its phases, celebrating rituals at the new or full moon. Lunar calendars still exist today in many cultures, shaping holidays and traditions across the world. Even our word month is rooted in the moon. Watching it shift night after night gave early observers a reliable rhythm to life. Unlike the sun's yearly cycle, the moon's shorter phases were immediate and visible. They tied the heavens to the daily needs of survival, turning the sky into a clock and calendar, long before humanity built its own. Lunar eclipses transform the moon into a copper orb. Every so often, the moon slips into Earth's shadow, and something extraordinary happens. Instead of disappearing completely, it takes on a deep coppery glow. This is a lunar eclipse. The reason the moon does not vanish is that Earth's atmosphere bends sunlight, filtering out the bluer wavelengths and casting the longer, redder light into the shadow. From the surface of the moon, Earth would appear as a black disk surrounded by a ring of fiery sunsets all around its edges. That crimson light bathed the lunar surface, reflecting back to us as the haunting blood moon. To stand beneath a clear lunar eclipse is to watch the moon become both familiar and alien, still hanging above, but changed into something shadowed, glowing, and strange. These events can last hours, giving everyone on the night side of Earth a chance to share in the view. Many cultures feared the blood moon as a night sky omen. The eerie red glow of a lunar eclipse has always stirred human imagination. In ancient times, before science explained the phenomenon, People often saw it as a warning. The Inca believed a jaguar was attacking the moon, staining it with blood. In parts of Mesopotamia, eclipses were thought to signal danger for kings, prompting rituals to protect rulers. Some Native American traditions describe the moon being consumed or wounded, inspiring chants and ceremonies to restore it. Across the world, the blood-red moon was a celestial omen of war, of famine, of change. Yet not all traditions feared it. Some cultures viewed the eclipse as a time of renewal or cosmic balance. Today we understand the science, but the sight still carries a primal weight. Watching the moon blush red in the night sky feels ancient, as though tapping into the same awe felt by every generation before us. A total lunar eclipse can last for more than an hour. Unlike the brief spectacle of a solar eclipse, a total lunar eclipse unfolds slowly and lingers. The moon drifts gradually into Earth's shadow, darkening, then glowing red. Once fully immersed, the total phase can last over an hour, sometimes close to 2. During this time, the moon hovers in its coppery cloak, its face dimmed but still visible. Everyone on the night side of Earth can see it, making it one of the most accessible celestial events. Ancient people gathered to watch, telling stories of gods, spirits, and omens. Today, families and astronomers still do the same, marveling at a spectacle that requires no telescope, only a clear sky. As the moon finally drifts free of the shadow, its familiar silver light returns, and the world feels restored. The slow unfolding makes a lunar eclipse one of the most meditative shows in the heavens. So eclipses sweep Earth with a racing shadow. When the moon drifts directly between Earth and the sun, a shadow falls upon the land. But this shadow is not still. It races across the surface, sweeping from west to east at speeds faster than sound. From above, astronauts see it as a dark, moving circle, crossing oceans and continents. On the ground, the approach is unmistakable. Light dims, the temperature drops, and silence falls over the landscape. Within minutes, day becomes twilight. Only those standing within the narrow path of totality experience the full eclipse, a fleeting window when the sun vanishes behind the moon. Ancient people surely felt fear as darkness rushed toward them. But today, many travel thousands of miles to stand in that shadow to witness the rare geometry of 3 celestial bodies aligned. It is a reminder of how delicate and precise the dance of the cosmos truly is. During totality, stars emerge in the daytime sky. Totality transforms the familiar into something dreamlike. For a few minutes, the sun's blazing light is blocked entirely by the moon, and a dark twilight falls in the middle of the day. In that strange light, stars appear. Venus often shines first, radiant and unmissable, followed by bright stars like Sirius or Regulus. Mercury may be spotted as well, something impossible on an ordinary afternoon. The world grows hushed. Birds settle into roosts. Insects begin their nighttime chorus, and the air feels cooler. Overhead, the sun's corona stretches outward, a delicate crown of light, usually hidden by the overwhelming brilliance of day. To see stars burn in the middle of the day is startling, a reminder that they are always there, patiently shining, whether we can see them or not. For those few minutes of totality, Earth feels suspended between 2 worlds, day and night intertwined. Ancient astronomers could predict eclipses with surprising accuracy. Long before telescopes, ancient astronomers watched the skies with careful devotion. They noticed that eclipses were not random, but part of repeating cycles. The Babylonians discovered the Saros cycle, a rhythm of about 18 years that allowed them to forecast eclipses with remarkable precision. In China, royal astronomers recorded eclipses as omens tied to the fate of emperors, keeping meticulous records stretching back thousands of years. The Maya aligned their great temples with the sun and moon, building calendars that perfected their movements. Even without modern science, these civilizations learned to anticipate celestial events that once terrified entire communities. To stand beneath a darkened sun and know it would return must have felt like power, proof that order lay within the heavens. Their careful records became the foundation for our own understanding, turning mystery into predictability and fear into reverence for the patterns of the cosmos. Venus shines so brightly in the night sky, it can cast shadows. Venus is no ordinary point of light. Often it is the first to appear in the evening or the last to fade at dawn. A steady lantern in the heavens. Its brilliance is so intense that under the darkest skies it can cast faint shadows on the ground, a trick only the full moon can otherwise perform. This brightness comes from its thick reflective clouds, which bounce sunlight efficiently back into space. To ancient people, Venus seemed twofold: the morning star rising before dawn, and the evening star glowing after sunset. Only later did they realize it was the same celestial body. Galileo's telescope revealed its phases like the moon, evidence that it orbited the sun. Today, we know its beauty hides a hostile surface where heat and pressure crush any visitor. Yet from Earth, Venus glows serenely, a radiant beacon bright enough to mark its presence with shadows. Jupiter gleams steadily, outshining most stars. Jupiter is the monarch of the planets, immense and commanding. To the naked eye, it shines as a steady point, brighter than almost every star. Unlike stars which twinkle through Earth's atmosphere, Jupiter's light is constant, unmistakable against the constellations. Ancient cultures revered it, tying its brilliance to gods of thunder, power, and rulership. Its steady glow masks a world of turmoil. Storms swirling in bands of color with a great red spot, a storm larger than Earth, raging for centuries. When it rises into the night, its presence is undeniable, drawing the eye and holding it. To follow Jupiter across the sky is to watch a giant in slow motion, orbiting far beyond our world, yet visible with startling clarity. Each time it gleams overhead, it reminds us of the scale of the solar system, where even the faintest glow hides unimaginable immensity. With binoculars, its moons appear as tiny jewels beside it. One of the simplest wonders of astronomy requires nothing more than a steady hand and a pair of binoculars. Look at Jupiter, and you may see 4 small lights beside it. These are its largest moons: Io, Europa, Ganymede, and Callisto. Discovered by Galileo in 1610, they shattered the belief that all heavenly bodies revolved around Earth. To the eye, they appear as delicate points aligned in shifting patterns night after night. Yet each is a world. Ganymede is larger than Mercury. Europa hides an ocean beneath its icy crust, perhaps home to alien life. Io is alive with constant volcanic eruptions. Callisto is scarred with craters older than recorded history. Watching them drift around their giant planet is to see motion on a cosmic scale. Proof that other worlds orbit far beyond our own. Even today, their quiet dance feels revolutionary as it did 4 centuries ago. Saturn's rings can be glimpsed through even the small telescope. Saturn is a planet of quiet beauty, golden and steady in the night sky. To the naked eye, it is lovely. But through a small telescope, the view transforms. Suddenly, a world appears encircled by rings, delicate and impossible. No other sight is quite like it. The rings stretch hundreds of thousands of kilometers, yet they are so thin they almost disappear when viewed on. They are made of icy fragments, some tiny as dust, others the size of mountains, all orbiting together in shimmering bands. Galileo saw them first, though his telescope was too crude to reveal their nature. Centuries later, they remain a favorite target for backyard astronomers. These rings are not eternal. They are slowly crumbling, raining particles into Saturn's atmosphere. In 100 million years, they may be gone, but for now, they remain one of the most exquisite spectacles the sky offers. Mars sometimes glows brighter than Jupiter with a ruddy light. Mars usually hangs modestly in the heavens, a small red ember among the stars. But every 26 months, Earth and Mars line up in opposition, bringing the red planet closest to us. In those moments, it outshines all but Venus, sometimes even Jupiter, glowing fiercely with a ruddy hue. Ancient people saw its fiery light as a symbol of war and blood, naming it after gods of battle. Through telescopes, it reveals ice caps, shifting dust storms, and valleys carved by ancient rivers. During great oppositions, Mars becomes striking, bright enough to command attention from even casual stargazers. Then it retreats, fading back into the background. Its brilliance comes and goes in cycles, a heartbeat between two planets sharing a cosmic neighborhood. Each close approach renews fascination, a chance to look across the void at a world both alien and strangely familiar, waiting for us to return. Mercury is elusive, hiding near the sun's glare. Mercury is a world of secrecy. Always hugging close to the sun, it rarely strays high enough to be seen easily. Most people have never glimpsed it, even though it is visible a few times each year. It rises briefly before dawn or sets just after sunset, shining faintly near the horizon before vanishing back into sunlight. To ancient observers, it was a quick wanderer, darting across the heavens with unusual speed. It was so tricky to follow that some cultures thought the morning and evening appearances were two different planets. When Galileo's telescope revealed its phases like those of Venus and the Moon, it became clear Mercury orbited the Sun. Today, it has stood a challenge, rewarding patient eyes during moments of greatest elongation. For those who find it, Mercury feels like a hidden treasure, a fleeting ember at the edge of day's light. Uranus and Neptune can just barely be spotted under pristine skies. The solar system extends farther than the ancients could imagine, into realms where faint worlds circle in silence. Uranus, a pale greenish dot, is just bright enough to be glimpsed with the naked eye from the darkest locations, though few ever recognize it. Neptune is faintest still, invisible without optical aid. Their discoveries belong to modern astronomy. Uranus in 1781 by William Herschel and Neptune in 1846, detected first by mathematics predicting its position. To glimpse them today is to look to the very edges of what can be seen from Earth. Through telescopes, Uranus appears serene, featureless, while Neptune reveals stormy bands of deep blue. They remind us that not all worlds reveal themselves easily. Hidden in the dark, faint, and slow-moving, they are silent sentinels on the outskirts of our planetary family, waiting for curious eyes to seek them out. Comets occasionally streak the night sky with glowing tails. Every so often, a visitor arrives from the depths of the solar system. A comet made of ice and dust ventures inward toward the sun. As it heats, gas and dust stream outward, forming a glowing kerma and tails that can stretch millions of kilometers. These tails always point away from the sun, sculpted by solar wind and radiation. Some comets become dazzling, dominating the sky for weeks. Hale-Bopp in 1997 and Neowise in 2020 captivated millions, drawing eyes upward. Others are faint whispers glimpsed only through telescopes. Comets have always stirred awe, for they appear suddenly and vanish without warning. Unlike the steady planets and stars, they are fragments from the dorm of the solar system, icy archives carrying secrets of creation. To watch one sweep across the sky is to see a messenger from the outer dark, ephemeral and timeless all at once. Some return only after thousands of years away. Comets move in elongated orbits, some circling the sun in a matter of years, others taking millennia. Those with long periods may appear once in recorded history, then vanish into the void until far future generations see them again. Their paths carry them beyond Pluto into the Oort cloud, a vast unseen reservoir of icy bodies of the solar system's edge. When gravity nudges one inward, it begins a journey measured not in lifetimes, but in civilizations. By the time it returns, languages may have changed, empires may have risen and fallen, and the world itself may be transformed. Imagine an ancient skywatcher recording a comet thousands of years ago, never knowing that the same body will blaze again in our own time. These long-period comets connect us across history. Their rare return stitching together the stories of countless human eyes turned skyward. Halley's Comet visits roughly once every 76 years. Among comets, one is legendary. Halley's Comet is bright, reliable, and well documented, returning every 76 years on average. Its appearances are woven into human history. Chinese astronomers recorded it in ancient times. It was depicted in the Bayeux Tapestry in 1066, seen as a portent of conquest. Mark Twain was born as arrived in 1835 and died during its return in 1910, famously predicting he would. Its path takes it deep into the inner solar system where sunlight ignites its icy surface into brilliance. Generations pass between its visits, making it a celestial link between grandparents and grandchildren. A reminder of how brief human lifetimes are compared to cosmic cycles. The next time it graces our skies will be in 2061. And once again, it will remind us of the continuity of time stretching far beyond individual lives. For centuries, comets were feared as omens of disaster. Before science revealed their nature, comets struck fear into human hearts. Unlike the steady stars and familiar planets, they appeared suddenly, blazing across the heavens without warning. To ancient peoples, their unpredictable presence marked upheaval, wars, plagues, the deaths of kings. The Chinese kept meticulous records of them, interpreting each as a heavenly signal. In Europe, they were dreaded hairy stars associated with fire and blood. Even into the Renaissance, comets carried reputations as harbingers of catastrophe. Only in the 17th century did astronomers like Edmund High begin to understand them as natural phenomena, icy wanderers following predictable paths. Today, comets inspire wonder rather than fear, but the weight of history remains. To imagine a medieval villager gazing at a blazing comet is to feel the raw awe these sudden visitors once provoked. Not beauty, but an omen from the dark beyond. Some comets have crumbled in full view of Earth. Not every comet survives its journey toward the sun. Some grow unstable as heat cracks their icy bodies and they break apart before our eyes. In 1994, comet shoemaker Lay 9 shattered into fragments that collided spectacularly with Jupiter, each impact leaving scars larger than Earth itself. More recently, comet EAM, once predicted to dazzle in 2013, disintegrated as it passed close to the sun, leaving only a faint trace. Watching a comet crumble reminds us that these objects are fragile, held together loosely, remnants from the solar system's earliest days. They can flare suddenly in brightness, then vanish forever, undone by the very star that reveals them. Their destruction is dramatic, but it also teaches astronomers about their composition, unlocking secrets from the dawn of planetary formation. In their fiery deaths, comets remind us of how delicate the building blocks of worlds can be. Auroras drape the night sky in shimmering curtains of light. In the far northern and southern skies, nights sometimes glow with ethereal light. Curtains of green, purple, and crimson ripple across the heavens, shifting and thickering as if painted by unseen hands. These are auroras, the northern and southern lights. They form when charged particles from the sun stream toward Earth and collide with our atmosphere, energizing atoms and making them glow. Each color comes from a different gas. Oxygen paints the sky green and red, while nitrogen glows blue and purple. For those who witness them, auroras feel alive, moving and pulsing with an otherworldly rhythm. They have inspired myths for millennia, spirits dancing, ancestors speaking, or battles waged in the sky. Even with scientific understanding, the beauty remains. To stand beneath an aurora is to feel the planet's connection to the sun directly above you, written in light, across the campus of night. These lights form when solar winds strike Earth's atmosphere. Auroras begin far from Earth in the furnace of the sun. Solar flares and coronal mass ejections hull streams of charged particles into space. Some of these reach Earth, where our magnetic field guides them toward the poles. There they strike the upper atmosphere, colliding with atoms of oxygen and nitrogen. Those atoms absorb the energy, then release it as light, creating shimmering displays that dance across the polar skies. The process is invisible from space, but breathtaking on the ground. Stronger solar storms make the lights more vibrant and push them farther from the poles, sometimes as far south as the Mediterranean or the southern United States. Each aurora is unique, shaped by the strength and direction of solar winds. To witness one is to watch Earth's shield at work, transforming invisible solar fury into beauty. Violence turned into luminous serenity. In the far north, auroras can appear almost nightly. For those who live in the high latitudes, auroras are not rare miracles, but recurring companions. In Alaska, northern Canada, Scandinavia, and Siberia, the auroral oval arcs across the sky, and during long winter nights, the lights may appear several times a week, sometimes almost nightly. Locals grow up accustomed to their glow, stepping outside on cold evenings to see the horizon pulsing with green or curtains rippling above. Tourists travel great distances in hopes of glimpsing them, waiting in icy darkness for hours. The aurora's regularity in these regions is a gift of geography. Earth's magnetic field funnels solar particles into those skies more often than anywhere else. Yet even for those who see them frequently, auroras never lose their wonder. They are both predictable and unpredictable, familiar yet never the same. Each night sky painted anew by the invisible hand of solar winds. Auroras also shimmer above planets beyond Earth. Earth is not alone in wearing these curtains of light. Other planets with magnetic fields also host auroras. Jupiter's are enormous, powered not only by the solar wind, but also by its volcanic moon Io, which spews material into space. These auroras can be larger than Earth itself, glowing in ultraviolet light, invisible to human eyes. Saturn has its own, tracing arcs across its poles, while even Uranus and Neptune display auroras shaped by their tilted magnetic fields. Mars, with only remnants of a magnetic field, hosts patchy auroras in localized regions. Studying these lights across the solar system reveals how planets interact with both their star and their own magnetic environments. It also reminds us that auroras are not unique to Earth. They are cosmic phenomena, written wherever winds of charged particles meet magnetic fields. What we see as beauty is a universal signature of energy. The zodiac constellations once guided planting and harvests. Long before calendars, humans looked to the stars for guidance. The zodiac, 12 constellations along the sun's path through the sky, became a celestial calendar. Farmers noticed that when certain stars rose at dawn or set at dusk, the seasons were shifting. The appearance of Virgo or Taurus might signal planting, while Scorpio's return marked harvest. This practical knowledge helped civilizations thrive, tying human survival to the motions of the heavens. Over time, the zodiac became more than a calendar. It evolved into astrology with constellations linked to personalities and fate. Yet its roots were practical, born from the need to measure time and anticipate the cycles of the Earth. Today, the zodiac remains familiar, though its stars have shifted slightly due to the slow wobble of Earth's axis. Its constellations remind us of the deep bond between human life and the rhythms of the cosmos. The ecliptic marks the sun's yearly path through the constellations. If you watch the sun from the same spot every day, it doesn't wander randomly through the heavens. Instead, it follows a steady path, tracing a great circle across the sky over the course of a year. This path is called the ecliptic. Along it, the sun appears to move from constellation to constellation, guiding the changing seasons. The moon and the planets stay close to this line as well, their orbits aligned with Earth's. For ancient sky watchers, the ecliptic was more than a pattern. It was the spine of the heavens, the stage where the most important celestial actors appeared. Even today, astronomers use it to map planetary positions, and astrologers place their signs upon it. When you follow the ecliptic, you're retracing humanity's first calendar, a line etched into the sky by the rhythm of Earth's orbit around the star that sustains us. Precession slowly shifts stellar positions over millennia. The stars feel eternal, fixed in their constellations, yet they are not perfectly still. Over thousands of years, Earth's axis wobbles like a spinning top. This slow movement is called precession, and it gradually changes the position of the stars in our sky. Today, Polaris sits almost exactly at the North Celestial Pole, guiding travelers as the North Star. But in ancient Egypt, around 5,000 years ago, it was a different star, Thuban, that held that place of honor. In another 12,000 years, Vega will shine where Polaris is now. Constellations too slowly shift, their outlines subtly changing as the background moves. To us, these changes are imperceptible, but across civilizations, they matter deeply, altering calendars and the alignment of temples built to track the heavens. Precession is a reminder that even the most seemingly unchanging things are still in motion, slowly rewriting the sky. The night sky looked different when dinosaurs roamed Earth. Imagine standing on Earth 100 million years ago when giant reptiles ruled the land. If you looked upward, the constellations we know today would not exist. Stars drift slowly over time, and the familiar patterns Orion, Ursa Major, Scorpius were arranged differently back then. Some had not yet taken the shapes we recognize, while others were skewed into unfamiliar forms. The Milky Way still arched across the sky, but its details would have appeared subtly different. Our ancestors never saw that view, but the dinosaurs did. Their world bathed in light from stars long since moved. To think that the heavens have shifted so dramatically reminds us how dynamic the universe is. Even the constellations we see as fixed landmarks are temporary, fragile pictures in motion. Millions of years from now, future skies will look strange to human eyes, just as they did to the dinosaurs. Some stars move so swiftly they distort constellations over time. Constellations are not permanent. They are illusions of perspective, stars at vastly different distances forming shapes by chance. Over time, individual stars drift, slowly altering these patterns. Most move so gradually we never notice, but a few streak across the background with unusual speed. Over thousands of years, these fast movers distort the constellations, bending their outlines. Orion's belt will one day look uneven. The Big Dipper's familiar scoop will eventually lose its shape. These changes happen over spans longer than a lifetime, but across millennia, the night sky transforms. Astronomers measure these motions as proper motion, a subtle shift against the background. By mapping them, we can predict the appearance of future skies or reconstruct the heavens of the distant past. The stars remind us that constellations are not eternal carvings, but fleeting alignments, momentary patterns in a universe where everything is always on the move. Barnard's star drifts faster across the night sky than nearly any other. One star, dim and reddish, moves faster against the background than almost any other. Barnard's star, a faint red dwarf just 6 light-years away, shifts its position noticeably even within a human lifetime. Astronomers call this proper motion, and Barnard's is the largest of all known stars. Year by year, it creeps across the sky, a restless traveler compared to its neighbors. Though invisible to the naked eye without a telescope, it has captured scientific attention for over a century. Once astronomers even believed planets orbited it, sparking speculation about alien life. Those worlds proved elusive, but the fascination remains. Barnard's star is old, perhaps twice the age of the Sun, and will continue drifting long after our world is gone. It reminds us that the stars we think of as fixed are not fixed at all. They wander, and some wander faster than others. Satellites drift like artificial stars across the night sky. If you watch carefully after twilight, you may notice a point of light moving steadily across the heavens. Unlike airplanes, it makes no sound and leaves no blinking lights. It is a satellite reflecting sunlight as it orbits Earth. Thousands of them circle above us now, forming a silent population of artificial stars. Their paths are predictable, rising in the west and gliding eastward before fading into Earth's shadow. Early satellites like Sputnik were greeted with wonder, their faint signals inspiring both excitement and fear. Today, constellations of satellites fill the skies, aiding communication, weather forecasting, and navigation. But their growing numbers also raise concerns about crowding the heavens. For the stargazer, spotting one is still magical. To watch a satellite glide overhead is to glimpse humanity's presence in space, small metal messengers joining the ancient lights that have shone above us for countless ages. The International Space Station often outshines everything but the Moon. The International Space Station, a laboratory orbiting 400 kilometers above Earth, is one of the brightest objects in the night sky. When sunlight catches its vast solar panels, it glows so brilliantly it can outshine every star and even rival Venus. To the naked eye, it appears as a fast-moving star, gliding across the horizon in just a few minutes. For those who know when and where to look, it is a thrilling sight, a reminder that people are up there circling the planet at over 27,000 kilometers an hour. Inside, astronauts live and work, conducting experiments and watching Earth pass beneath them 16 times a day. The station itself is a symbol of cooperation, built by nations working together. Each time it crosses overhead, it connects the vastness of the sky with the human story, a bright reminder of our fragile presence in space. Satellite flares can briefly rival Venus in brightness. Some satellites do more than simply glide, they flare. When sunlight reflects off their surfaces at just the right angle, they flash brilliantly, outshining nearly every object in the sky. The old Iridium satellites with their flat antenna panels were famous for this, producing dazzling bursts visible even from cities. These flares could rival Venus in brightness, startling those who happened to be watching. They last only seconds before fading back into the background. For astronomers, they were both a nuisance and a wonder. Light pollution in one sense, but also a striking example of orbital mechanics at work. Even as satellite designs change and the Iridium flares fade into history, new reflections still surprise stargazers. To see a sudden flash from an artificial star is to witness the interplay of sunlight, geometry, and technology, a fleeting spark linking Earth to the machinery circling above. Rockets sometimes paint glowing trails across the upper atmosphere. When rockets launch, their fiery engines cut through the atmosphere, leaving glowing trails that can stretch for hundreds of kilometers. At high altitudes, these plumes expand and catch the sunlight, even when the ground below lies in darkness. The result is a spectacular vision, luminous clouds twisting and spreading, shimmering with rainbow hues as ice crystals scatter light. To onlookers who do not expect it, the sight can be startling, resembling a supernatural phenomenon. In truth, it is human technology meeting the upper reaches of the atmosphere where thin air and sunlight combine to create beauty. These displays are often visible across entire regions, turning ordinary evenings into unforgettable experiences for those who happen to glance upward. They remind us that even the work of rockets, machines of fire and force, can leave behind moments of wonder written gently across the sky. The night sky has grown busier with human-made lights in orbit. For most of history, the sky belonged to nature alone. Stars, planets, comets, and meteors were the only moving lights. But in just a few decades, humans have added thousands of their own. Satellites, space stations, and debris now circle the planet, many reflecting sunlight as they pass overhead. To the naked eye, these appear as moving stars, crossing paths with constellations and streaking through long exposure photographs. For astronomers, the growing swarm poses challenges, interfering with observations and leaving trails across images of the universe. Yet for ordinary sky watchers, the sight can be strangely comforting, proof that Earth has reached into space, leaving its own quiet signature. The heavens have become a shared space between natural wonders and human creations. Each artificial light is a reminder of our species' ambition and of how quickly we have filled even the quietest places with traces of ourselves. The Hubble Space Telescope revealed breathtaking deep-sea vistas. Launched in 1990, the Hubble Space Telescope has shown us the universe as never before. Orbiting high above the blur of Earth's atmosphere, it captures images with clarity no ground-based telescope could match. Its views of galaxies, nebulae, and star clusters have become iconic, filling books and screens with colors and detail. The pillars of creation, the Sombrero Galaxy, and countless glowing clouds of star birth have entered our imagination because of Hubble. Beyond beauty, it has provided crucial science, measuring the age of the universe, tracking the expansion of space, and uncovering the secrets of distant worlds. For more than 3 decades, it has circled Earth, offering a window into the depths of time and space. Each of its images is a reminder that the universe is not an abstract concept, but a place of vast beauty, waiting patiently to be discovered. Every patch of darkness hides a multitude of galaxies. If you find a patch of night sky that looks empty and stare deeply into it, you might expect nothing more than blackness. But when astronomers turn powerful telescopes towards such regions, they find something astonishing. Within what seems to be blank space are thousands of galaxies, each containing billions of stars. Every tiny speck of light captured is an entire island universe unimaginably far away. The realization is humbling. The emptiest corner of the sky is anything but empty. It teems with galaxies stacked across time, their light traveling for billions of years before reaching us. This means that whenever we look at darkness, we are not staring into void but into abundance. The night's quiet spaces hold more worlds than we can fathom, hiding richness behind what appears to be absence. Emptiness, it turns out, is an illusion. The Hubble Deep Field uncovered thousands in the space no larger than a grain of sand. In 1995, astronomers pointed Hubble at a patch of sky so small it looked utterly empty. For 10 days, the telescope stared into that darkness, gathering faint light. The result was extraordinary. Nearly 3,000 galaxies appeared in that tiny view. Later, deep fields revealed tens of thousands. To grasp the scale, hold a grain of sand at arm's length. The area it covers is about the size of the Hubble Deep Field. If so many galaxies exist in such a minuscule fraction of the sky, then the entire cosmos must hold hundreds of billions. Each galaxy contains billions of stars, each with the potential for worlds and perhaps life. That single experiment transformed astronomy, proving that the universe is richer and more crowded than anyone dared imagine. It showed that the most ordinary patch of black sky hides unimaginable abundance. Time itself flows differently across the cosmos. Einstein's theories revealed that time is not universal. It bends and stretches under the influence of gravity and motion. A clock ticking near a massive star runs more slowly than one far away. A traveler moving close to the speed of light experiences time at a different pace than someone standing still. This means the universe does not share a single rhythm, but countless rhythms woven together. In extreme cases, near black holes for instance, time slows dramatically, almost to a halt from the perspective of an outside observer. Astronauts in orbit experience a tiny difference from us on Earth. Their clocks running slightly faster or slower depending on altitude. Time is not fixed, it is elastic. The stars above remind us that even something as fundamental as time itself is part of the cosmos, strange fabric shaped by the gravity and motion of the heavens. Every star in the night sky is a glimpse into the past. When you look up at the stars, you are not seeing them as they are now. Light takes time to travel, and even the closest star beyond the sun is more than 4 years away. Many are hundreds, thousands, even tens of thousands of years distant. That means their light began its journey long before the moment you see it, carrying with it a glimpse of the past. Some of the stars you admire may already be gone, their fuel spent, their brilliance extinguished, though their final light is still en route to Earth. To gaze upward is to look back in time, seeing the heavens not in the present, but as they once were. The night sky is a cosmic archive, each star a page of history written in light, reaching us only after unimaginable journeys across the gulfs of space. Some are so distant their light began before humans existed. There are stars and galaxies so far away that their light has been traveling for millions of years, long before humans first walked the Earth. When you see them, you are gazing into epochs where our planet was ruled by dinosaurs, or even into ages before mammals had evolved. The photons that strike your eyes tonight set out on their journey long before humanity appeared, long before there were even forests or flowering plants. Some of that light began its trek in a universe unimaginably young, when galaxies were only beginning to form. To look at such distant objects is to step outside of human history entirely into a timeline written in starlight and distance. The stars become not just ornaments of the night, but messengers of deep time, telling stories older than humanity itself, stretching far beyond the span of life on Earth. The cosmic microwave background is the afterglow of creation. In every direction, faint radiation fills the sky, invisible to our eyes, but detectable with radio instruments. This is the cosmic microwave background, the afterglow of the Big Bang. Nearly 14 billion years ago, the universe was hot, dense, and filled with light that could not escape the thick plasma. As the cosmos expanded and cooled, that light finally streamed free, filling all of space. What remains today is a faint echo, cooled to just a few degrees above absolute zero, but still present everywhere. First discovered accidentally in the 1960s, it has since become one of the most important clues to our origins. Tiny fluctuations in this afterglow show where galaxies would one day form. To study it is to peer into the universe's infancy, when the first light escaped into darkness, and creation, its earliest memory, was written across the sky. Though invisible to our eyes, it permeates all of space. The cosmic microwave background is not confined to one corner of the heavens. It fills the universe completely. No matter where you point an antenna tuned to the right frequencies, the signal is there, faint, steady, and ancient. In fact, a small fraction of the static once seen on old television sets came from this background radiation, whispers of the universe's birth arriving in every home. Though invisible, its presence is undeniable. It tells us that the cosmos was once unimaginably hot and uniform before expanding into the vast, varied place we inhabit now. To know that every patch of space carries this same signature is humbling. It means that no matter where you stand on Earth or anywhere in the universe, you are bathed in the same relic glow, the quiet memory of a creation that still lingers around us. The heavens once held the first galaxies forming at cosmic dawn. Billions of years ago, when the universe was young, the first galaxies began to form. Clouds of hydrogen and helium collapsed under gravity, igniting the earliest stars. These stars were massive, bright and short-lived, living fast and dying in brilliant explosions. Their deaths seeded the cosmos with heavier elements, the raw material for planets and life. These galaxies were small and chaotic compared to the great spirals and ellipticals we see today. But they were the pioneers, stitching light into darkness. Astronomers call this period the cosmic dawn, the time when the universe first began to glow with starlight. To see them now requires peering across immense distances and timescales, catching their faint glows. It was over 13 billion years ago. They remind us that everything we see today, every star, every world, every living being traces its origin back to that dawn. The James Webb Telescope peers back towards that dawn. Launched in 2021, the James Webb Space Telescope was designed to look farther back in time than any telescope before it. With its massive gold-coated mirror and instrument sensitive to infrared light, it can detect the faint glow of galaxies that formed only a few 100 million years after the Big Bang. Already, Webb has revealed galaxies brighter and more massive than astronomers expected so early in cosmic history, challenging our understanding of how the universe grew. Its images show newborn stars wrapped in clouds of dust, planets orbiting distant suns, and light stretched into red by the universe's expansion. Webb peers into epochs we could only imagine before, bringing us closer to the cosmic dawn when the first galaxies sparked. Each discovery reminds us that the universe still holds surprises, waiting to be uncovered in the faint light, traveling to us across billions of years. Some stars orbit the galaxy's center at dizzying speeds. At the heart of the Milky Way lies a supermassive black hole, a gravitational anchor around which everything revolves. Most stars circle the galactic center leisurely, taking hundreds of millions of years to complete one orbit. But closer in, the pace becomes astonishing. Some stars, known as SSRS, whip around the black hole at thousands of kilometers rs, completing an orbit in just a handful of years. Observing them has given astronomers direct proof of the black hole's immense paw, an invisible force revealed only by the frantic dance of nearby stars. From Earth, these stars are faint pin-pricks of light, but their motion tells us volumes. They remind us that even the quiet night above is filled with furious speed and invisible gravity. Their dizzying orbits are a glimpse into the raw power that lies at the very heart of our galaxy. Hypervelocity stars are flown outward like slingshot stones. Every so often, a star is caught in a deadly encounter with the black hole at the center of the galaxy. If it approaches too closely, tidal forces can tear apart a binary pair, capturing one star while hurling the other outward at incredible speed. These exiles are called hypervelocity stars, and they race through the Milky Way at millions of km/h, fast enough to one day escape entirely. To the naked eye, they are indistinguishable from ordinary stars, but careful measurements reveal their extraordinary velocities. They are cosmic fugitives torn from their homes by gravity's violent sling. Each carries with it a history of turmoil, a story of close brushes with destruction. To think of stars themselves wandering into intergalactic space is humbling. Entire suns cast adrift, traveling alone into the endless dark, never to return to the galaxy that once birthed them. Rogue planets wander invisibly through the night sky without suns of their own. Planets are usually bound to stars, but not all remain tethered. Some are ejected from their systems, sent adrift through the galaxy. These are rogue planets, lonely worlds that wander the dark without a sun to warm them. Invisible to ordinary sight, they can number in the billions, perhaps outnumbering stars themselves. Some may carry thick atmospheres or subsurface oceans, heat preserved by internal energy or radioactive decay. If life could exist in such places, it would thrive in perpetual night, forever hidden from starlight. Astronomers detect them through subtle gravitational effects, watching for the faint bending of background starlight as a rogue world passes in front. Each discovery deepens the mystery of how many such exiles may drift unseen between the stars. They remind us that not all planets belong to familiar systems. Many wander alone, silent and cold, across the cosmic void. Vast clouds of dust obscure entire regions from view. The heavens appear clear and transparent, but vast regions of space are veiled. Interstellar dust, fine grained smaller than smoke particles, floats in great clouds that block visible light. These clouds can obscure entire clusters of stars, turning rich regions of the Milky Way into dark patches. To ancient observers, they looked like holes in the sky, places where stars were absent. But we now know they are nurseries, places where stars are born from collapsing gas. Within them, gravity pulls material together until new suns ignite. Though dust hides their brilliance, it also protects fragile beginnings from harsh radiation. These clouds are paradoxical. They conceal and they create, hiding stars while giving rise to them. Through infrared and radio light, astronomers peer inside, revealing structures unseen to the human eye. The darkness between the stars, it turns out, is full of birth and becoming. Infrared light pierces these clouds to reveal hidden suns, while dust blocks visible light. Longer wavelengths slip through. Infrared radiation, invisible to human eyes, reveals the stars and structures hidden within dark nebula. Telescopes tuned to these wavelengths can see newborn suns glowing in their cradles, wrapped in cocoons of dust. They also expose planetary disks, the beginnings of solar systems forming around young stars. Missions like the Spitzer Space Telescope and the James Webb Telescope have transformed our view, turning opaque shadows into landscapes alive with hidden light. Where the naked eye sees only blackness, infrared shows clusters of suns, filaments of gas, and galaxies veiled by their own dust. It is like lifting a curtain on the universe, revealing what lies beneath. The cosmos is not empty where it looks dark. It is filled with hidden brilliance, waiting for the right kind of vision to bring it into sight. Radio waves from quasars travel across billions of years to reach us. Some of the most powerful signals in the universe come not from nearby stars, but from quasars, brilliant active galaxies with supermassive black holes at their centers. As matter spirals into these black holes, it heats to extreme temperatures, blasting radiation across the spectrum, especially in radio waves. These signals cross unimaginable distances, traveling for billions of years before they reach Earth. Quasars are so distant that many shine from a time when the universe was young, only a fraction of its current age. They are lighthouses from the deep past, their steady emissions cutting across time and space. Radio telescopes on Earth capture their faint whispers, transforming them into data that reveals the growth of galaxies and black holes. To listen to a quasar is to hear echoes of a cosmos still in its adolescence, voices carried forward from the earliest chapters of creation. Some quasars blaze brighter than whole galaxies combined. Though they are powered by black holes, quasars are anything but dark. They blaze with such intensity that a single quasar can outshine every star in its host galaxy. Their brilliance comes from matter spiraling inward, heated to millions of degrees as it falls. Some emit jets of particles stretching for millions of light years, colossal beams visible across the universe. To the eye, a quasar looks like a faint star, but behind that point of light is energy greater than entire galaxies. They are cosmic paradoxes, destruction and creation entwined. Quasars illuminate the distant universe, marking the locations of galaxies from the time when the cosmos was still assembling. Their light crossing billions of years reaches us as a record of both violence and beauty. To know that such brilliance exists so far away is to realize how powerful the engines of the universe truly are. Gamma ray bursts shine for moments yet outshine the universe. Among the most violent events known are gamma ray bursts, fleeting explosions that release more energy in seconds than our sun will emit in its entire lifetime. They are thought to occur when massive stars collapse into black holes or when neutron stars collide, sending shock waves through space. For a brief moment, their light overwhelms the combined output of every star in the observable universe. Most last only seconds, some just milliseconds, before fading into afterglows detectable in X-rays and radio waves. They are so distant that their light often began traveling billions of years ago. Yet they still dazzle our instruments today. Though invisible to human eyes, gamma-ray bursts are caught by specialized satellites, alerting astronomers to their fleeting presence. To witness such power, even indirectly, is to confront the extremes of the cosmos. Explosions that briefly eclipse creation itself before vanishing into silence. The night sky is alive with signals across the spectrum. When we look upward, our eyes capture a mere sliver of the universe, visible light. Yet, the cosmos hums with signals across the full electromagnetic spectrum. Radio waves flow from distant quasars. Microwaves echo the birth of the universe. Infrared warmth radiates from dust clouds. Ultraviolet streams from hot young stars. X-rays blaze from Black's air. Holes and gamma rays flash from cataclysms. Each band reveals a different layer of the same story. The quiet sky is in truth buzzing with information, a symphony of light at many frequencies. Astronomers build instruments tuned to these wavelengths, creating a fuller picture of the universe. To see only invisible light is to glimpse just one note of a vast cosmic chord. The night above is not silent or still. It is alive with hidden energy, signals constantly weaving through the dark, carrying the history of everything. Every glance upward is a look into the history of the universe. When you raise your eyes to the stars, you are not just seeing space, you are seeing time. Every point of light is a messenger from the past, its journey stretching across years, centuries, or billions of years. The farther away it is, the older the story it carries. The nearest stars show us years ago. The Andromeda galaxy shows us millions of years ago. The faintest galaxies we can detect reveal the universe as it was shortly after the Big Bang. The sky is a vast archive, its light layered like the pages of a book. Each glance upward is not into the present, but into memory, the universe showing us itself as it once was. To lie beneath the stars is to lie beneath history itself, immersed in a chronicle written in light, stretching back to the very beginning of time. And so, dear listener, our journey through the wonders above comes to a close. From shadows racing across Earth during eclipses to the quiet glow of planets, from comets that sweep by once in a lifetime to the soft curtains of aurora that ripple in the polar skies. We have wandered together through a tapestry of light and time. We have glimpsed the brilliance of stars burning far away, felt the silence of galaxies stretching into the dark, and traced the faint echoes of creation still lingering in the heavens. The sky reminds us that existence is vast, ancient, and endlessly surprising. It shows us both the immensity of the cosmos and the delicate threads of light that tie us to it. Every star overhead is a messenger from the past, every planet a reminder of possibility, every shadow and shimmer a story still unfolding. As you lie here, letting your breath fall into an easy rhythm, imagine yourself beneath that infinite canopy. Picture the hush of a clear night, the cool air around you, and the endless constellations turning slowly overhead. See the sweep of the Milky Way arching across the dark. Comets trailing silver fire and distant galaxies flickering like forgotten lanterns. All of it flowing into stillness, into memory, into dreams. The sky has carried countless generations before us, and it will carry countless more. Its story is not finished, and in gazing upward, neither is ours. Just as day gives way to night, every waking thought drifts gently into sleep. If you happen to still be awake, you can go ahead and watch the next video when you are ready. But if your eyes are growing heavy, let the quiet of the heavens hold you and carry you softly into rest. Close your eyes, breathe deeply, and drift into sleep, into stillness, into the vast and timeless silence where stars themselves keep watch. Good night.